So, what's fermentation?
What do you think fermentation is?
I don't know what it breaks down into.
You get 2 ATP from glycolysis, and then they don't undergo aerobic respiration, so they produce lactic acid, and then also produce ethanol and CO2.
With something with yeast? I don't know.
Isn't that when the sperm goes in the egg or something?
So, as you can see, fermentation is something that many people have heard of, but not many people understand.
But fermentation is actually in a lot of things that we use in our everyday life.
Glycolysis, meaning breaking of glucose, is the one process that aerobic and anaerobic respiration have in common. As portrayed in the name, the cycle begins with one glucose molecule, which is a 6-carbon chain. First, 2 ATP are used in the process, causing there to be an output of 2 ADP, an inorganic phosphate. After this, 2 NAD+, the electron carriers, are reduced and become 2 NADH. Following this, 4 ADP, inorganic phosphate, enter the process, causing there to be a product of 4 ATP. After all of these molecules have entered and left, the glucose molecule has successfully broken down into 2 pyruvate molecules, which are each composed of a 3-carbon chain. At the end of it all, the products of glycolysis are a net creation of 2 ATP, 2 NADHs, and 2 pyruvate molecules. The reason that the product is 2 ATP and not 4 ATP is because 2 ATP are ultimately used in order to provide energy that allows the process to occur. In anaerobic respiration, the pyruvate from glycolysis can enter one of 2 processes, either ethanol fermentation or lactic acid fermentation. Ethanol fermentation begins with the 2 pyruvate molecules, which consists of an oxygen molecule bonded to a carbon molecule, which is double bonded to another oxygen molecule. This carbon is attached to another carbon, which is double bonded to an oxygen, and the last molecule is a methyl group. This pyruvate molecule is then transformed into an acetaldehyde molecule, which consists of everything the pyruvate molecule has, except the first oxygen has been replaced with a hydrogen molecule, and one carbon double bonded to oxygen has disappeared. This carbon and the 2 oxygen molecules have joined to create carbon dioxide and have left the process. While these processes are occurring, NADH, an electron carrier, has carried 2 hydrogen ions to the fermentation cycle. These 2 hydrogens are then added to the acetaldehyde to create 2 ethanol molecules, and this causes NADH to be oxidized into NAD+. At the end of it all, the products of ethanol fermentation are 2 NAD+ molecules, CO2, and ethanol, of course. Ethanol fermentation is used in the production of items like beer, wine, or really any alcoholic beverage. Lactic acid fermentation starts off with 2 pyruvate molecules from glycolysis, like in the beginning of ethanol fermentation. This is then transformed into 2-lactate, which gains 2 hydrogen ions from the NADH that came into the process from glycolysis as well. Once the hydrogen molecule is attached to the pyruvate, the NADH is reduced into NAD+, and is sent back into glycolysis. Ultimately, lactic acid fermentation results in the creation of 2 NAD+ and 2-lactate. Products such as yogurt and cheese are produced using this method of fermentation. However, lactic acid fermentation also occurs within mussels.
So, in order to find out more about the real-life applications of ethanol fermentation, we decided to take a trip over to Bond Brothers Brewery. So, we are on the way to Bond Brothers Brewery right now.
Yes.
And we are about to meet with the head brewmaster, Mr. Baker.
So I started home brewing 6 years ago, and me and my buddy Jeremy, who's one of the Bonds, were brewing at his house. And at that time, so that would be my 3rd year teaching. So then we taught 5 more years, and then we opened this place. So that's kind of the timeline there. So I went to school. I have a degree in biology and education and science. So I like teaching science. So that kind of rolled into being nerdy about beer also. So the 2 major variables in fermentation are pressure and temperature. So specifically the pressure, the weight of the water on top of the yeast, and then the temperature. Raise the temperature, you can ferment faster, but the yeast will make more esters, and that's a combination of a acid and an alcohol. And that lends qualitatively in beer to fruity flavors, so like banana or red apple or that kind of stuff. And if you have too much pressure, the yeast will actually just die. and when the cells autolyze, they get like a hammy or like a cooked ham flavor.
Do you spend a lot of time trying to get those ratios right?
So there's the qualitative aspect again. So it's like if you're looking at the water chemistry for each beer is different also, and you're shooting for different parts per million of different ions in your water.
Right.
Basically, you're looking for a number, say 50, right? But if you were to hit 40 or 70, you wouldn't be able to tell the difference in taste. So there's a good margin of error where even if you're about right, it's going to turn out okay. So.
But about like the fruity flavor that you guys put in beer. So was that?
So the yeast put it in.
The yeast put it in.
Yeah,
Could you expand on it a little bit more?
Yeah, sure. So basically the two, if you guys are talking about whether it's like, well, I guess let me break it down. So there's lager and ale, and those are two different species of yeast.
Right.
And with ale yeast, there's kind of regionalities. There's an American yeast, English yeast. There's a lot of different types in that zone. Kind of like breeds of dogs. But then there's the Belgian style of yeast, and so every yeast puts off what are called esters, which are a fruity flavor. So, for example, isoamyl acetate is the name of the compound for banana we just talked about. Right. And not only do certain yeasts put it off, but also actually physical bananas have that same chemical in them. So it's made by either bioprocesses in a banana or in the fruit itself, or from yeast. Kind of the chemical pathway is the same. With the isoamyl alcohol and the acetate kind of forming that ester. The other compound that Belgian yeasts put off, like wheat beer or hef yeast or other Belgian yeast, are phenols, and those are they have a benzene ring. They're like aromatic compounds, and so those are the two main flavors you're qualitatively controlling when you ferment with a yeast, as far as so higher temperature, higher growth. So if you put less cells into the beer, they'll grow more, and as they grow more, you'll have more esters, so you'll have more fruit flavor. Okay. So you can kind of control that by adding more yeast to begin with, which would have less growth, and then you have less fruity flavors. So most of these conical tanks we use for fermentation, and they all kind of have different beers in them every time. The water tanks there, those are for carbonation, so that's where the beer gets carbonated. So we take the yeast off of the beer, put it into those containers, and then it's carbonated there. So basically the four main ingredients for beer, you got water, yeast, malt, and hops, right? Right. This is the room where we take the malt and we crush it. That's basically it. Right. We crush it in this white tube, has a kind of like a spring in it that we turn a bunch in an auger. So that carries the grain up over to vessel number 2, which is back that way. Okay. And so this is kind of where we have a cool biological process going on. So this is where the starch turns into sugar with alpha and beta amylase. You may know from if you like chew a cracker, chew a saltine, it gets sweet in your mouth. That's your mouth amylases. So we kind of soak the crushed grain in hot water here to kind of catalyze that reaction into taking the starch from the grain where it wouldn't be sweet to start with, turning it into a sweeter kind of sugary syrup. Right. And then if you want to take a closer look here, this grate right here, that's how we can separate the solid from the liquid. So we make this sugar water, and then we basically open a valve at the bottom and then collect the sugar water and leave the solids behind. From here it goes to there. And so here is the boil kettle. So we have this sugar water, and this is where we add ingredient 2, hops. This is our air stone. So one of the things, the next step is fermentation. And one of the things we do to make sure that the yeast grow well and have good flavors is we actually add a certain amount of oxygen in there. So the sterols and the cell wall can be kind of propped up because alcohol is ethanol is a toxic environment for yeast. Right. So they don't have enough oxygen to make strong enough cell walls. They'll die and they get that hammy flavor we're talking about. Right. A lot of what we do here in this part of the process is kind of set up with the yeast health in mind. So we'll add zinc, make sure the pH is right. For most beers, between like 4.9 to 5.1, that's where yeast grow best. Then we'll add the right amount of oxygen as well to make sure that the yeast are comfortable, because if the yeast aren't comfortable, or if they have trouble maintaining homeostasis, they will basically give off flavors. They'll have bad flavors in the final finish.
Right.
Yeah. That stuff is going to gloss over. We do this thing, we make the sugar solution with some hops in it.
Right.
And then we prep that liquid for yeast. And then we bring it over to here. Here's the beer fermenting. These things are what we ferment the beer. And so that gets done in about 8 hours.
Wow.
But from when we pitch the yeast to when we pull it back out, that can take up to 4 weeks. So the yeast work for a while. We got basically this one's still fermenting over here. And you know, after we get the beer finished, we will then kind of take the yeast back out of it, use it again, and put this over to one of those squat tanks, the one down there on the end there, and that's where we carbonate it, and then we take it and serve it. So like if you're measuring alcohol and stuff, the yeast will be physically done making alcohol and CO2 faster than they're done cleaning up a lot of the metabolites that you look for if you're like, again, qualitatively analyzing the beer. Specifically diacetyl, which is a butter compound, and acetaldehyde, which is green apple flavored or latex flavored. Those two compounds are kind of the two of the last intermediates before the yeast convert them all the way to ethanol and CO2. And so typically the yeast will leave a bunch of that behind, and then your job sort of as the brewer is to kind of manipulate, usually increasing the temperature, but manipulating the environment to make sure they eat all of those compounds as well, and completely convert them into ethanol and CO2, and then make sure you don't have bad flavors in your beer, basically.
What's the difference between like beer fermentation and then like fermentation within like wine or like?
Okay, so beer fermentation and wine fermentation are pretty much identical in that they are consuming sugar and they're basically turning it into ethanol, CO2, and heat. Where you get like different fermentations, vinegar production is a difference. So non-alcoholic beer is typically made when you make a regular beer. That requires like a special facility. It's a basically it's kind of a modified distillation process. Yeah, so it's a low pressure vacuum to remove the ethanol, but leave the other particles. So in a non-alcoholic beer, they make alcoholic beer and they take the extra step to actually remove the ethanol that way. You can't actually make non-alcoholic beer to start with.
So now that we learned more stuff about ethanol fermentation, we are going to try baking bread, which uses ethanol fermentation as well. So we're done visiting with Mr. Baker. So now we're going to go home and try some baking of our own.
Hey everyone!
Hi!
So today we are going to be exploring fermentation through making some homemade bread. So
the recipe includes basically a sponge and then like a dough part. Fermentation occurred and the yeast made the sponge rise.
And you can even see some bubbles there.
The holes show CO2. And then the dough also has yeast in it.
Very true.
So that will help our whole bread rise. Because fermentation lets out CO2. Caroline is going to tell us about some interesting fun facts of fermentation.
Fun fact! So did you know that consuming higher rates of fermented foods leads to lower rates of social anxiety within young adults? That's pretty neat. Yay, fermentation.
And it'll be easier to mix. Maybe I'll even mix it with my hands. Don't worry, I'll wash my hands first.
Hey guys, it's time for another fermentation fun fact. So although fermentation can be a little bit daunting because it involves a lot of microorganisms and bacteria, which can sometimes have a negative stigma, the USDA has actually found that there are no foodborne illnesses that come from fermented vegetables, meaning that they're sometimes safer to consume than raw vegetables. And so basically we are just going to wait for an hour now because we have finished making the dough. If you want to show everyone what that looks like over here. So
looks really good.
Yeah, it looks very good. And so now we have to wait an hour for the dough to rise, and it's going to rise because ultimately CO2 is going to enter the dough and it's going to cause it.
Because of fermentation.
Yeah.
The self-rising or rapid rise yeast. Used inside of it. So it should double in size.
It should double in size, but we will check back with you guys in about an hour.
1 hour later.
Okay, so it's been an hour, and as you can see, the dough has doubled in size, and this is because the yeast has fed on the sugars within the flour, so it releases carbon dioxide in order to allow the dough to grow.
Yep, and right now we're just gonna grease the spatula and we're going to fold it, and then we're probably gonna have to wait again, so.
All right.
Okay, so the bread has finished baking, but now I'm going to cut it. Let us see how this works out. I've cut the bread, and I might even try a little bit without Caroline. But as you can see, there are some holes inside the bread, but the holes inside the bread are caused because of the yeast fermenting. And so since the glucose is being broken down, the pyruvate molecule, which turns into acetaldehyde, it loses CO2. And that CO2 fills the bread and causes it to rise, which leaves these holes inside the bread where the CO2 was. And yep, so the bread turned out really good.
From mussels to yogurt to alcohol, fermentation is most definitely an important biological process.
And without it, we wouldn't have so many of the things that we have on our earth today.
Dude, what even is yeast?
I don't even know.